Okay, hello everyone, back again. Hopefully you've been refreshed with a cup of tea or something. We'll start on the last session. We've got 3 presentations to go, so it's just about an hour or so, if I can manage to keep everybody on time. Massive variation, as I mentioned, in the talks and the subject matter. This one is no exception. We're back in the air. We had satellites previously. So we're now at a talk on the imperative of extending the ISO 19100 series standards for global air mobility. And this will be presented by Wanshu Zhang from the Shenzhen Geospatial Information Center. Thank you.
Okay. Dear colleagues, it's a great honor for us to present on the imperative of extending ISO 19100 series standard for global air mobility. My name is Wanshu Jiang. For some special reason, Dr. Liu cannot show up here, so I wish I could present it clearly. Okay. We will analyze the development of global air mobility from 4 aspects, examine the limitations of the ISO 19100 series standard in supporting air mobility, demonstrate the necessity of extending the standard, and put forward new recommendations. First, let's see the overview of the development of global air mobility. Urban air mobility is called UAM. Manned aircraft system, we can call it UAS. And US traffic management, we call it UTM, are evolving at an unprecedented pace, transforming not only how we travel, but also creating new opportunities for economic growth. However, to fully realize this potential and ensure safe and reliable operations, we need a more solid foundation. And that's precisely what standardized geospatial information can provide. From this map, we can observe that urban air mobility, unmanned aircraft system, is traffic management in the phase of rapid expansion worldwide. Whether in North America, Europe, or the Asia-Pacific region, numerous research projects, technology tests, and the formulation of regulatory framework are in progress. Market forecasts also indicated significant growth in these sectors in the coming year. It's reported, it's estimated, and it will reach up to $1 trillion by 2050. Despite the growth in low altitude air mobility, the market remains in its early stage with significant regional disparities. The US, Europe, and Asia are developing divergent regulations and standards, posing challenges to global interoperability. Harmonized international standards are essential to overcome these barriers and enable seamless cross-border operations. While the ISO 19100 series provide a robust foundation for geographic information management, we must acknowledge that its generality presents certain limitations when addressing the unique challenges of this emerging field of urban air mobility. The core objective of this report is to delve into these shortcomings and propose specific recommendations for extending existing standards or creating new ones. Second, let's see the limitations of ISO 19100 series for global air mobility. The operational environment for urban air mobility is a complex three-dimensional space involving various elements such as buildings, flight corridors, and vertiports. The existing ISO 19107 standard faces certain challenges in modeling these intricate urban airspace structure with sufficient detail and precision. The current ISO 100 series has limitation in effectively modeling the highly dynamic airspace, including temporary restrictions, no-fly zones, and real-time traffic information, which are crucial for UTM. In addition to basic temporal reference, more complex temporal patterns are needed to capture the dynamic characteristics of airspace availability and usage. Although ISO 19108 addresses the temporal aspects, it may not provide the granularity and specific structure required for the rapid and frequent updates peculiar to UTM operations. ISO 19018 focuses on the temporal characteristics of geographic feature. However, the airspace in UAS UTM is not just a feature with one time frame, but an entity whose availability and restrictions may change rapidly and unpredictably according to various operations and safety factors. The ISO 19100 series lacks specialized standards for cataloging elements and infrastructure specific to US and UAM, such as vertical takeoff and landing airports, charging stations, combination network, and designated flight corridor. A standardized approach is needed to define these attributes and relations of these unique elements. The UAM and US UTM ecosystem relies on infrastructure and elements not commonly found in traditional GIS applications. The current ISO 19100 series lacks standardized method to define and catalog these unique elements, thereby hindering data sharing and interoperability within the field. Effectively managing and discovering data related to unmanned aircraft system, urban air mobility, and US traffic management require comprehensive metadata, while ISO 19115 provides a good foundation. It may need extension to include the specific details such as the exact model of UAV or drone, its operational parameters, and the coverage area of UTM services. The airspace environment for UAV and urban air mobility is often dynamic with restrictions availability, changing rapidly based on operation condition. The existing ISO 19100 series lacks the dedicated standard to handle this dynamic effectively and support the exchange of real-time airspace information, which is crucial for safe operations. A third proposed extension. Given the invitation discussed, extending the ISO 19100 series of standards become paramount. This facilitates data interoperability between different systems and actors, enhance the safety and efficiency operations, and provide a solid standardization foundation for the healthy development of global market. Extension 1, to effectively model the complex three-dimensional urban space where AOAM and many US operations occur. We recommend extending the ISO 19107 spatial schema by introducing specific geometric perimeter and topological relationship tailored to aviation needs. Extension 2, to better represent the dynamic nature of airspace and flight operations in the air mobility domain, we propose extending the ISO 19108 to incorporate more refined temporal concepts such as event-driven changes and flexible scheduling. Extension 3, to ensure effective data discovery and management within the air mobility domain, we recommend extending the ISO 19115 metadata standard to include specific metadata element uniquely describing the characteristic of UAV, UAM operation parameters, and UTM service details. Extension 4, to provide a location-based service for air mobility, we should add extension to ISO 19132, such as add UTM-specific viewpoint service, upgrading ISO 19133, such as provide interfaces for ADS-B traffic surveillance integration, and adapting ISO 19134 for airway networks. To address the critical need, the new standard, to address the critical need for managing dynamic airspace in air mobility, we propose developing a new ISO standard specially for this purpose, defining data models for representing temporary airspace restrictions and real-time traffic data, and ensuring seamless integration with existing aeronautical information system. And last, collaboration is a key. The development of these extensions and new standards should not occur in isolation. Collaboration with other key standard bodies such as OGC and European Organization for Civil Aviation Equipment is crucial to ensure alignment, leverage existing expertise, and avoid duplication of effort. In conclusion, extending the ISO 19100 series through our proposed enhancement to temporal and spatial models, the development of a dedicated feature catalog and metadata standard, and the creation of a new dynamic space management standard are crucial steps in effective supporting the global development of air mobility. Okay. Oh, sorry. At last, we urge ISO TC 211 to consider these proposals and initial necessary work to develop and implement these extensions and new standards. Also, call upon all experts and stakeholders to actively collaborate and participate in future refining these recommendations and working together to establish a robust and future-oriented standardization framework for the exciting field of urban air mobility, unmanned aircraft system, and US traffic management. And last, we have the national project of China to support this research. This research includes the urban modeling and information strategy for low altitude flight, temporal information acquiring services, environmental risk assessment and system development. Okay. Okay, thank you. If you are interested in this topic, please contact me and let's make a contribution to air mobility together. Okay. Okay, thank you.
Thank you. Thank you very much. All our standards at ISO are under a 5-year revision process. If there's anything significant that comes up before then, we will consider it. So I would suggest the best way to take some of this forward would be to work through your National Standardization Committee, and they would work towards TC 211. I do take the point regarding flight corridors. Something like 107 was originally written 20 years ago or so, and we were concerned about 2D spatial data at that point. Yeah, it's now into 3D, but yeah, you're probably right. It probably doesn't consider things like flight corridors, which is a very complex world. But yeah, do reach out. Okay. Does anybody get any other questions on that? Yep, Scott.
Have you looked at the ANSI document, the ANSI UAS standardization collaborative roadmap of potential standards? Okay, so I'm going to write this down and I will send that to you because it covers a lot of these same standards. Yes, and it's very American-centric, but some of the ideas are uniform, and I'll send that to you. But I've written personally a very draft geofence standard, and I'm trying to find other people to collaborate with me and get it into OGC and TC211. So if anybody volunteers to help me finish the geofence standard, I think it'd be really valuable. I think that belongs in the geomatics community and does not belong in the UAS community because it's more universal.
Thank you, Scott.